Okay, so here we have the 2014 acid-base question. You can see that it came up as a full question in question 7, so that was worth the full 50 marks. So the first part asks us to distinguish between a Bronsted-Lowry strong acid and a Bronsted-Lowry weak acid. So by the Bronsted-Lowry theory, we know that a strong acid is a good proton donor and a weak acid is a poor proton donor. Okay. Next up, they give us the dissociation of this nitrous acid. And if you read the first sentence in that question, it tells us that it is a weak acid. So we know by the Bronsted-Lowry theory, it's a poor proton donor. By Arrhenius's theory, it dissociates in water to produce, or it dissociates slightly in water to produce hydrogen ions. So they ask us to identify the two substances acting as bases in this equilibrium. So what we need to do is kind of track the before and after dissociation of each substance. So we can see that the HNO2 becomes NO2 minus after dissociation. So in order for that to happen, that has to lose or donate that hydrogen ion. So that means that our HNO2 is our acid, which we knew already. And when an acid behaves like an acid and gives up that hydrogen, it becomes a conjugate base. Let's have a look at the water now. The water, we can see, gains that proton to become this H3O plus, which is our hydronium ion. So that means that the water in this equation is behaving like a base. And when a base behaves like a base and accepts a proton, it forms conjugate acid. So the question asks us to identify the two substances that are behaving like bases. Well, they are the water and the NO2 minus. So our answer there is H2O and the NO2 minus. Okay, so that was part B. Now let's have a look at part C. So part C, they ask us to, first of all, define pH. And we know our definition for pH is just the equation that we use to calculate it. So it's minus the log to the base 10 of the H plus ion concentration. Now they tell us the pH of a 2 molar solution of nitrous acid is 2. Calculate the concentration of the H3O plus ion in this solution in moles per liter. Okay, well, another way that we can write this pH equation is minus log to the base 10 of the H3O plus ion concentration, or the hydronium ion. So we've been told in the question that that equals to 2. So in order to calculate that concentration, we're going to bring the minus across, and then finally we take the inverse log of that, and it will give us a concentration of 0.01 moles per liter. Now they ask us to explain clearly how this H3O plus ion concentration confirms that nitrous acid is a weak acid. Well, if we have a look at the initial concentration that they tell us in the question, the initial concentration is 0.2 molar. And what we have just calculated is the hydronium ion concentration after dissociation, and it is less than the initial concentration. So the concentration here is 0.01. The initial concentration was 0.2, so it's less than the initial. And what does that mean? That means that it has only partially dissociated, which means that it's a weak acid. Okay. Then they ask us what concentration of nitric acid would have the same H3O plus ion concentration. Okay, just get that out of the way. Okay, so what concentration of nitric acid? Now, nitric acid is a strong acid. So that simplifies things a little bit. Because we know that a strong acid completely dissociates. Plus OH minus. And actually, I'm going to rewrite that as the H3O plus. We know that that's going to dissociate in water. Okay. NO3 minus, excuse me. So we know the nitric acid is strong, which means that it fully dissociates. So we're looking for the original concentration of nitric acid, given that it has the same H3O plus ion concentration as what we calculated in the previous question. So basically, we've got 0.01 molar of this hydronium ion. Because it's a 1-to-1 ratio, we know that that comes from 0.01 moles per liter of nitric acid. So now we have our original concentration of our nitric acid. Finally, they ask us to calculate the concentration of the OH minus ion in both of these solutions. Okay, so we know that the pH plus the POH equals 14. And the POH is 14 minus the pH. We know that the pH is equal to 2, which is equal to 12. So that's our POH. And we want to calculate the concentration of the hydroxide ions. So in order to do that, we're going to use our minus log to the base 10 of the hydroxide ion concentration. We know that that's equal to 12. Sorry if you can hear my dog walking around, his claws on the wooden floor. So that is equal to 10 to the power of minus 12. So we use our inverse log there. So the hydrogen ion concentration is 1 by 10 to the minus 12 moles per liter. Okay, part D is a little sneaky test for anion question. So they ask you to describe how you would test for the presence of the nitrate ion. Now I'm not going to write that out now because it's a different chapter, but it's your brown ring test. So if you're not 100% sure on that, have a look at the marking scheme and go back and have a look at your notes. And then part E is linked with our water chapter. Explain how nitrate levels can result in a reduction in the dissolved oxygen content of lakes and rivers. So that brings us back to our eutrophication. So nitrates are used by algae, and they cause, if we've got a high amount of nitrates, it results in a rapid growth of our algae. Remember our phrase, live fast, die young. So as they die, the bacteria decay the algae, the oxygen gets used up during that decay, and that prevents or that reduces our dissolved oxygen content. So again, that's in our water chapter, so have a quick look back at that if you're not 100% sure. So 18 marks there of this question were actually not technically acid, base, and pH, which is something that they like to do in the questions, so don't get thrown off when they mix different chapters. Okay, so that's the 2014 question. If you have any questions on that one, just send me an email.